Good morning, everyone. How's audio?
Sounds good.
All right, and folks can see the slides.
I can see them.
Cool. Thanks, Arndt. Let's give folks maybe a minute or two, and then we can get the show on the road. Hey, Justin, how are you?
Hey, everybody. Is my audio coming through okay?
Pitch perfect.
Excellent. I can never tell which microphone a given meeting software is going to pick. So, all right. Should have the. So, Peter, I should have gotten the slides up into the data tracker this morning. Did you see that go through?
I saw Brian's slides go through.
Yeah, Brian's slides.
Brian's slides,
Yeah, those.
Shall we give folks another minute or two?
Sounds good. Does anybody want to volunteer for taking notes? Yes, Brian, slides on behalf of the Workload to Workload team. I can at least partially take notes.
Dimitri, did I hear you say you will take notes as well?
Yeah, I swear I did.
I can also help out with notes.
Awesome, thank you.
Get logged in.
Today, 16. Okay.
All right, shall we get going?
Let's get going.
Right, so welcome everybody to the WIMSE interim. This is the first of, I think, four that we've scheduled. And just as always, right, note well, everything we do here is covered by code of conduct and by under the rules of the IETF. And our OKRs for today is there will be a welcome, and so we have achieved this. And then there will be some additional OKRs about workload to workload authentication that Brian will share with us. And I'm sorry, I saw you had a request to share slides, but
yeah, if you put that through again, we can grant that to you. All right, I've got it.
Good man.
Excellent. So before we dive in, unless you are presenting or asking a question, please stay off of mic and video. Peter and I are going to be off. There we go. Are going to be off in the background here ourselves. And also, because this is one of our interim meetings, we are going to keep the conversation dutifully focused on specifically workload to workload authentication and Peter and I reserve the right to aggressively table any side conversations. As always, final decisions are made on the list. And with that, Art, please take it away.
Thanks, Justin. Yeah, so this is us. First interim. I think there's a second topic for us as well, but this is the first one, and we have a very specific topic today. I guess the picture displays Montreal 2019. I'm not sure what's the reference situation in Montreal, but we picked this for some inside joke instead of having some AI generated interim picture, I guess. All right, today's agenda is that we're quickly going to talk about the recent updates we've made since Madrid. Then we're going to recap about the structures we describe in the draft, like the X509 version, the WIPIT, and the HTTP message signatures. And we're also going to rehash the kind of debate we've been having for a long time, like on the note of WIPIT versus HTTP message signatures. All right. So since Madrid, we've been reworking a bit of the workload proof token, WIPIT, OTH claim. OTH stands for other token hashes. Previously, this was a single string where you could put anything you may be transmitting along a message in there, and we kind of did not really like that. So now it's actually a bit more structure where you can put multiple based on the header, etc. But we'll be bringing this up again in Montreal. It's just more like a quick update. We also updated the media types and some editorial stuff. Cool. Let's dive in. So our current workload to workload authentication WIMSE adopted document describes two types of credentials. We talk about the workload identity certificate and the workload identity token. One is particularly used for network layer authentication. That's the certificate. And there it's basically straightforward. It's all TLS based, basically mutual TLS on the transport layer. So far so good. That's been there since the beginning, and there's quite clear. On the other hand, on the application level of layer authentication, we do define this workload identity token. And on application layer, that is particularly useful when you have, like, for example, middleware boxes that you have like some API gateways, or you have a service mesh where you kind of want to authenticate on the application layer, not directly on the network. The workload identity token, that is also straightforward. It's a token that kind of you send over the wire, where you kind of tell about your identity, and in that token is a public key via the confirmation claim, CNF. And with that token, you need to also send along proof of key possession. And there we have two different approaches. One of them is HTTP method signatures with RFC 9421, and a workload proof token. We call this WIPIT. It's easier to say. And there, it's like these two approaches have been around from the beginning. And there's been a lot of conversations whether we need to have both, whether we should focus on one, and each of them has like different benefits and drawbacks. And yeah, today we want to focus on this conversation. Yeah, and also to highlight what's the benefits, what's the drawbacks, and just get like the feedback from the working group and come to a decision, because this is like the biggest decisions we have to make on our way to working group last call. So we'll now quickly go over the different things we have, just to kind of give again an overview, but that's going to be super brief. So this is a workload identity certificate. It's an X509 certificate, very straightforward, and we do define this SAN extension, subject alternative name extensions, where you have to have at maximum one URI. That can be a SPIFFE identifier, WIMSE identifier, but you can also then add additional stuff like DNS, etc. Yeah. That's the workload identity certificate. You present it over mutual TLS. It's very straightforward. The next one is the workload identity token. That's also there, straightforward. It's a it's a JSON Web Token, header, body, and the relevant part is the CNF claim, where you kind of have the public part of a key, which is like kind of the key that belongs to the workload. And the workload, every time it presents this token, has to provide proof of possession. It is not a bearer token because you do need to provide that proof of possession. It does not have an audience that will be in the proof of possession. And you do post it over the workload entity token header and not on the authentication header, particularly because it is not a bearer token. Yeah, now we're going to have Brian talk about the WIMSE proof token, and then maybe Yaron about the HTTP method signatures. I'll keep the shares.
Thanks, Art. I agreed to talk about this because I wanted to put all these pictures on here, and I was told I had to explain it. The WIMSE proof token, WPT for short, and we started recently calling this the whippet. So I include some whippets, both in dog and t-shirt form there, and of course the famous Devo song, "Whip It Real Good." The whippet, though, is also a JWT, that is used as the authentication proof of possession piece in conjunction with the WIT. So it is sent alongside it and is bound to the particular transaction or request being made there through the audience claim. So in this one, you can see the HTTPS URL of where this request is being made. It also has an expiry and a unique identifier should there want to be any sort of replay checking on it, check for duplication. Additionally, there are a couple of claims required and or allowed within the token that basically can bind it to an access token or a transaction token via hashing of that token and inclusion inside here, which is then, of course, signed over with the key from the CNF claim of the WIT, and as well as the OTH for the hashes of other tokens, should they be sent or required in context. But what this does is basically bind in the user and or authorization context of the request inside of the whippet, allowing for that to be the proof of possession to be bound to where the request is being sent and authorization or user context of that request as well. It also has a WTH. That's close to an acronym that might sound like something else, but it's not, that binds back to the WIT through the same mechanism of just a hash. This was kind of superfluous, but also valuable to kind of bind in that context and allows for some other content to be omitted from the whippet that would otherwise be like duplication of various like other claims. If you just kind of like hash back over the whole WIT, you don't need to do any of that because it's all sort of included by transient reference. And this thing is sent in an HTTP header that we define and aspire to register, called the workload proof token.
Thanks, Brian. Yaron, I don't know if you're able. Perfect, thank you.
I am actually, thank you, Art. So the other option is to use HTTP message signatures. And we see an example here. Basically, the WIT is sent on the wire as is. That's the workload identity token header, obviously. And the keeper that's bound to the WIT, where the CNF is the public key, that keeper is now used for an HTTP message signature. The draft specifies exactly what needs to be covered by the signature, and that includes, as you can see, the method and the request target, as well as the WIT itself. It is also optional, so this is for the request, and according to the draft, signing the response is optional, but still possible using the same mechanism. So HTTP message signatures. If the sender and receiver are using any kind of custom headers, it's easy to extend the signature to cover such headers as well. So yeah, that's it. Message signatures as an HTTP specific option.
Thank you, Rowan. Okay, moving on. So this discussion has been around for a while. Here you can see an issue that I created July 15th after, I think that was Vancouver, IETF in Vancouver, basically more than a year ago. And since then, this discussion has been ongoing a bit, but we kind of always delayed it. And yeah, now here we are. Yeah, so that is Vancouver. Yaron?
Yeah, if I may, we actually had this discussion formally within the working group once. We, the editors, believe we need to reopen this discussion now that we have a more stable version of the draft and possibly more understanding of how things fit together.
Thank you. Okay, because we've been talking a lot about this and there's some subtle differences between these two approaches, we kind of try to summarize them on this page to also highlight some quite significant differences between those two. So both of them, obviously, which is like kind of the main focus, is provide proof of key possession capabilities. Yeah. Then another topic is the integrity protection of an HTTP message. And this is something where HTTP message signatures with its capability to, for example, have the signature include a content digest and basically any HTTP header you want to include, allows for integrity protection of the HTTP message, where the workload proof token with the URI of the target in the audience has only this, and in the end does not provide integrity protection of the message content. And so it covers some headers, but certainly not all. Yeah. On the protocol side, HTTP message signatures only work obviously with HTTP messages, while the workload proof token can be easily adaptable to other protocols, including asynchronous delivery, like for example, Kafka messages, etc. On the technology required, yeah, maybe not the best wording, but what we are trying to say here is that with HTTP message signatures, you need to have the capability to open a short token or verify a JOSE signature, and you need to be able to verify or attach HTTP message signatures for the proof of possession. Whereas with the workload proof token, you only need that JOSE signing verification capability for both of these credential mechanisms. Yeah. And then, of course, the response signing is something that is part of the HTTP message signatures, but the workload proof token does not bring that capability. Yeah. And the TLDR is basically that HTTP message signatures is specialized and feature-rich, but it's limited to HTTP, whereas the workload proof token is lightweight and potentially more deployable. right? You can deploy it beyond HTTP, and you can also have it for like asynchronous delivery. Yeah. Justin, go ahead.
Yeah, clarifying question here. Has anybody done work to deploy workload proof tokens beyond HTTP, or is this conjecture?
As far as I know, that work has not been done. But the use cases are definitely there.
Noted, but then the word easily adaptable is doing a lot of heavy lifting here on this slide.
Yeah, that's actually, we had this discussion. That's why we added this potentially.
Okay.
Yep.
Thank you.
Yeah, but Justin's talking about some wording up higher, which
Oh, I see. Yeah.
which
Fair.
I wrote and believe to be true, be it conjecture.
Yeah, and yes, that's fine. And my goal with raising the comment was to gauge whether this was conjecture or whether we had running code on this part yet, because that should be clear to the group.
Yep.
Where this is coming from. All right,
From
thank you guys.
Yeah, from a actual like conjecture standpoint, it likely is as straightforward as adjusting the audience for the given target and validating it appropriately. But agreed, it is only conjecture at this point.
Okay. We do believe that the integrity protection is a vital part. And that's why we have a separate slide on it. So, as I said in the beginning, workload-to-workload communication sometimes includes middleware proxies that is able to read and potentially modify the message. Some outgoing reverse proxies, ingress controllers in Kubernetes, service meshes, etc. And HTTP message signatures includes certain aspects of the HTTP message, like, for example, headers of your choice, the content by default, and that is included in signature and thus protected, integrity protected. And the whippet does not protect the message and is simply said just a way to demonstrate proof of key possession. And what's also important that due to the fact that certain parts of the message are included in signature, when using HTTP message signatures, it's very unlikely to allow a replay unless it's like the exact same HTTP message. While with the whippet, it's just about the audience, right? So you can potentially replay a token with the same proof of possession to the same endpoint because that is what's in the audience, and thus this is allowed. Within the short lifetime of the whippet, obviously, but yeah. So when integrity protection is desired, right, then HTTP message signatures provides a standardized way to achieve that. Okay, so from the WIMSE working group, we now have various options, various ways to go. So as of today, the draft is published today is that we allow for whippets and HTTP message signatures in the draft. We also highlight a bit the differences, but we also believe that developers should not need to make that decision, right? So as of today, as a developer, you kind of have to, or like implementer of the draft, you need to make the choice whether you want to go A or B. And yeah, that can be tricky because we do try to help, but it's a decision a developer needs to make. Another option is to allow only for HTTP message signatures. Then the counterpart is to only allow for the workload proof token. Both of these options kind of come along with the option to just consider a different structuring of the document. And if we would go with the whippet approach, we could also allow or like extend the whippet to kind of add integrity protection into it, right? So kind of add certain claims into it, like build something similar than HTTP message signatures. Yeah, I think we can open the queue and mic for discussions. If you want to slide, yeah.
Brian, you've got your hand up.
Yeah, thanks, Peter and Arndt. I just wanted to try to frame the context here a little bit better. We've hinted at it, but as Wood says, we've had both of these sort of proof mechanisms in the document from the very beginning. Leading up to IETF 120 in Vancouver, we brought it to the attention of the working group, and the feedback in that working group meeting was overwhelmingly to keep both options in the document. But the editor's team largely thinks that one would be preferable to two, but we cannot agree amongst ourselves which would be preferred. And so that's kind of how we ended up back here at this question in front of the working group. But I don't know how much of that kind of came through in the prior part of the presentation, but I wanted to sort of restate a little bit about the history and how we got to here we are now. And it looks like I copied 2 arrows there. There only needs to be one from working group to only whip it. But hopefully that's clarifying. If not, thanks for listening anyway. Thanks.
Fleming. Thank you, Brian.
Thank you. Can you hear me?
And we can't hear you clearly.
Okay, let me try again. Is that any better?
That's a little better, yes.
Okay. So I agree that it is definitely desirable to only have one method in here. So, from that point of view, I definitely support the notion that was just given before. As to which one to prefer, obviously it's been shown here, right? There are multiple paths, but maybe we should hold off on deciding that and first of all figure out, does the group agree that there should only be one, or does the group think that there should actually be two? If we could get consensus on that, then maybe it'll be easier to discuss, okay, where do we then go from there?
Thanks, Fleming. Yaron?
So yeah, only representing myself, I'm very much supportive of the orange box, so of only having one option for the developer, and then channeling my inner Brian, the option of extending Whippet to include message integrity is risky in the sense that it could lead to the amount of, mainly complexity, code complexity, and draft complexity, document complexity, as we have in HTTP message signatures. It's not impossible, but it's not great either.
Thanks. Yaroslav.
Hi. Yeah. I think that there is room for all three, especially given that eventually we want to support non-HTTP things and potentially non-TLS things. I know that today charter limits us to HTTP. That should be our focus. That should be our focus. So maybe we just extract one of the method and make it a separate draft later on if we feel there is a need, so we might have a compromise solution. Other point that I would like to make from the application developer's perspective, and I really appreciate that Arne brought this up. Right now things are very complicated, right? You have to make a decision and then you have to live with this decision, and changing the way you do you reason with workload identifiers is a dramatic change in the application. So perhaps having like an abstraction layer or having some commonalities between mechanisms that this draft proposes and encouraging providers of APIs to abstract away implementation detail could be step in the right direction to make this zoo of different mechanisms more straightforward. And then another final point that I would like to make regarding to TLS certificate, I think one important design decision that have to be made when choosing between TLS certificates versus other mechanisms is with TLS certificates you do cryptographic operation only once when TLS session is established, and then within the tunnel you could potentially have plethora of HTTP requests, while with other mechanisms you have to do it per request. I don't think this is reflected currently in the draft, so perhaps worth opening an issue about it. Thank you.
Hey, so chair hat on. I do want to raise the point that we are currently chartered to focus on HTTP. We are not disallowed from doing work that also benefits non-HTTP stuff, but that was an intentional limitation in the chartering of this group to make sure that we stayed focused. So do keep that in mind as we make this decision. Chair hat off, I want to echo what Yaron said about adding the complexities of integrity protection into whippets. It's a pattern we've seen happen before with Depop, where Depop added more features into it as time went on, and the security model wasn't as simple as it originally was thought to be. And that type of complexity has a way of constantly creeping up on you. So again, this is chair hat off, pointing out that effectively adding in HTTP SIG functionality to another way to do that is clearly possible because it has been invented, but may not be the best use of time, attention, and resources.
Thank you, Justin. Peter Castleman, chair hat off for a moment. Both of these mechanisms appear to be solving slightly different problems, right? I think, Arndt, you had a great slide earlier that compared them. And something that, I can imagine that we will have use cases. We will have use cases for both, right? One observation is it is kind of unusual to describe a credential type, workload identity token in this case, but X509 certificates is a similar thing, and then be restrictive about which protocols they're allowed to be used with, right? You can use an X509 cert with MTLS, you can use it with SMIME, there is, IPsec, right? There is a vast number of protocols that you can use a X509 cert with, and consequently, that's not prohibited. It's sort of considered a good thing. So, my mental model for this is, okay, so we have two potential, call it protocols, that we would use workload identity tokens with. And it's really going to depend very much on your infrastructure and your deployment models and what problem you're trying to solve. And so I get the desire to have only one, but it does seem unusual since we don't really restrict other credential types that way, right? So I just wonder if that is maybe a false choice that we are considering. And it would actually be interesting also to hear from other folks on the call. I mean, this, of course, is a discussion that will have to go to the list potentially, but it would be good to hear from other folks on the call who are addressing different use cases, and really also sort of thinking about if there is only one or the other, will it actually change how we think about adoption, right? Will it be inhibiting adoption or accelerating it? For example, would the absence of HTTP message signatures mean that, say, oh, I don't know, maybe the MCP community does not consider WITS as a viable authentication mechanism, or does the absence of workload proof tokens mean that maybe in the SPIFFE community, it sort of dilutes the need for supporting workload identity tokens? And I'd like to just maybe hear from other folks as well. Arndt.
This is me as an individual. I do worry that if we pick HTTP message signatures, all the folks that cannot use it because they don't use HTTP, for example, they use gRPC or some other protocol, will have to build their own proof of key possession capability. So eventually we would end up with both again, right? Maybe not in this draft, but out there we would have multiple as well, right? So I'd rather have something generic where other people can really, if they want, maybe then add their integrity protection over it, where they can use mutual TS as well on top of it if they want to. Then focus now on one, where on the paper it looks like it's just one option, but out there in the world there will be multiple anyway, right? Because all the ones that cannot use HTTP message signatures will need to build their own on top anyway.
Okay, I think it's me. So Joe Salloway, I think one of the things I'm concerned about is that with going in the direction of the workload proof token, I think we will have feature creep for security requirements or other reason to try to add more things into that token if that's the option that we go with. And so that concerns me that we'll be going down that path anyway. One of the approaches that, I think Yaroslav mentioned that I think might be a way forward here is maybe to go with HTTP signatures for HTTP right now, move the workload proof token to another draft that can be there for as we take on other protocols. And maybe we have an example other protocol that we can start working on sooner rather than later. I'm not sure how that fits into the charter though. So that's just my concern. Thanks.
Who's next? Noah.
Yeah, sorry, I was a little bit confused about the order of the hands up there. Yeah, so I think I would just echo Arndt's point a little bit there. I'm a vendor in the space, and I've spoken to a number of our customers about the kind of draft workload to workload specification. And I'd say there's been a lot of excitement around the workload proof token and this distributed proof of possession flow. Particularly for customers, I know we've already mentioned gRPC, but also other things like asynchronous messaging. There's kind of plenty of cases where HTTP message signatures are not going to be a good fit, and that does sort of lead me to believe that if we don't see the formalization of the WIPIT somewhere, people are going to go off and build it anyway, kind of in different places, right? I am interested in the idea of maybe splitting the specs up. That seems like a good way of approaching this. But yeah, that's kind of my thoughts on the topic. I think, as speaking as someone kind of on the SPIFFE 6 spec side, if we didn't see the WIPIT as part of IETF, then maybe it's something that we would discuss kind of at the SPIFFE level separately, because I think I've spoken to enough people who are kind of interested in the WIPIT as a solution for other protocols.
Noah, just for a moment, putting my chair hat on to Justin's earlier point, it sounds like there is no implementations, but I'm also curious. I'm kind of curious, right? Given that you have customers who are interested, what is keeping them from doing implementations?
That's definitely a good question. For a lot of people, it's just a maturity thing, right? I think people are kind of they look at their current stacks and how they currently have this kind of mishmash of different technologies, many of which are not kind of abiding to any standards. And I think they're kind of keen that if they're going to put the time and effort into introduce something new and start migrating towards it, they kind of want to choose something that is standardized, right?
Okay.
So I wanted to jump the queue with a chair and charter note, because this has been brought up a couple of times. It is fully within our remit to publish our deliverables in as many or as few documents as we should choose. So we are fully empowered to split things and reshuffle things if we feel that that is the best way to deliver this to the community.
Fleming, you're back. Fleming?
I am. Thank you. Yeah, Peter, actually addressing your comment earlier, and to some extent what Art was saying as well, I think it's important that we make a clear distinction between the identity and the identity format itself versus how do we get away from just having this as a bearer token, right? Because those are two separable mechanisms, and that's really what we're discussing here. So I know you were expressing a desire to only have one mechanism, right, and one identity format across all the different transports, and I agree with that. Having said that, though, if you go with the workload proof token, you will still need to do more specification that says, this is how I will do it with HTTP transport to get the same set of security properties as I get with the message signatures. You will need to say something about how do I do it with gRPC, et cetera, et cetera. So my point is that I think even with workload proof token, you are going to be needing some transport specific considerations, but you can still have a generic WIT no matter what. So I'm not convinced, right, that the workload proof token in and by itself is basically addressing the concern about saying, well, we really just want to have a single way of doing everything.
Oh, maybe just to quickly respond to that, Fleming, I think my comment was more that the workload identity token is that credential, right? That is the thing that is binding the key to the identity of the workload. And then the proof token is really this proof of possession mechanism. And maybe, yeah, just in case that was not clear. That was the thing that I would thought of as being common. The workload proof token to me is just another way in which to use a workload identity token, or another mechanism with which to use a workload identity token.
But the proof token is essentially addressing the issue around the WIT just being a bearer token, right? I mean, you're going to have a WIT no matter which approach you're going with here. And the WIT looks the same, right?
Right, and that is the point, right? Just like an X509 cert looks the same, regardless of which protocol or mechanisms you use it with. And we don't really prohibit, we don't really prohibit which protocols an X509 certificate can be used with. It can be used with any number of protocols, right? And likewise, to me, this kind of looks like the same. It's depending on your environment, you're going to pick one or the other, right? So depending on what your needs are, you'll pick differently.
Right, but just to make sure we're saying the same thing, irrespective of whether we have one or two mechanisms here, irrespective of which one it is, if we go with two, the WIT stays the same. Right?
Exactly, yes. Yes, we're agreed on that. Thanks, Fleming. Yaron. Sorry, that was all chair hat off discussion, by the way. Yaron.
Yes, so to riff off on some of the things that Ant and Joe said, I would like to put a more specific proposal on the table and suggest that we have HTTP message signatures in this document for classic HTTP REST transport, as well as an appendix with the WIPIT as the agreed upon solution by the working group for future protocols. I mean, some would say that that our charter doesn't cover future things. Yeah, that may be true, or that we shouldn't worry about the future. That's arguable. I think most of us know that there is a future beyond HTTP REST, and yet, in my opinion, we should have one solution for HTTP REST, and then have Whippet proposed for asynchronous gRPC and so forth.
Thank you, Yaron. Justin.
Yeah, just wanted to chair hat off. I wanted to point out that having a normative working group opinion in an appendix that puts effective constraints on future work of the working group feels real weird to me. And it's entirely possible that I am just garden pathing on a detail of what Yaron said. So we don't need to debate this, I honestly don't think. But I do think we need to be careful about what it is that we are recommending within our docs.
Okay. Sorry, Arndt, I skipped over you.
No worries.
That'll teach you for not having a picture up on your profile.
Okay, I guess I'm pretty sure Brian has a picture in mind. So two things. So I wanted to say that the reason, like, there is no implementation of non-HTTP protocols for the Whippet, but I, at least myself personally, always had it in mind when designing this, right? And it's always been a topic, at least for myself. And on the whether this is one document or multiple, maybe as a suggestion is there's the there's the 75, 21, 22, 23 documents, where 21 is the generic one, and 22 is for SAML, and 23 is for auth, right? So we may do something similar here, where we say, okay, we have workload entity credential and workload entity token in the core document, and then have two profiles of it, one for HTTP and the other one for maybe async messages, right? I do not want to put one into the main document and the other split out, because that's even more confusing for people, right? And like, at first, when I look at it, be like, okay, that's just HTTP, not relevant for me. So if we do something like this, I would keep the core that is generally usable in one document, and then have multiple profiles based on the protocol.
Thanks, Arndt. That kind of resonates with me. Again, chair hat off, but I that makes sense, so that it could become more confusing for people that way. Yaroslav.
I have a question for Yaron. In terms of applicability for HTTP, so Yaron, you said a few times that it's all very specific to REST, if I heard you correctly, but I don't see any reason why this wouldn't apply to, well, GraphQL or, I don't know, WebSocket or Web Transport or any other thing that you can legally put inside HTTP 1, 2, or 3? Or is there some dependency that's making it all specific to REST?
Peter and Joe, if you allow me.
Yes, please.
So I was using REST very, very, very loosely, basically synchronous HTTP.
Okay. Joseph? Joe? Oh, Arndt is back in the queue, I see. Arndt. Oh, no, he's not. It's Joe. Joe, it's your turn.
Me. Sorry, I just was having trouble with the little buttons. Yeah, so What I kind of wanted to bring up was that I think its point's been made before, but I just want to reiterate. Like, we have experience more with HTTP right now than we do with the other protocols. And while Whippet, it looks like a good generic mechanism, it may be when we go to a specific protocol, I don't know which one, that there is some construct native to that protocol that we might extend to, that might be better suited than Whippet. So I'm a little bit concerned maybe we're putting cart before the horse. On the other hand, it is a good generic mechanism, and it there is utility there. It just may not provide as much security or integrate as well as a native mechanism in one of these other messaging or other type of protocols. Thanks.
Thanks, Joe. I actually also had a question for Yaron. Chair hat off. The question is really about if you would keep everything in one document. I'm kind of curious about your thought process there. Why would something be in an appendix? What's the difference between having the content in the appendix and having it where it is today in the main document? What would be the benefit of the appendix?
No, today we have two options for implementers, for people who deploy this solution. I personally and others don't think that's ideal. Whether it's an appendix or not, I don't really care. The point is to have only one choice for the developer, while still, in my mind, keeping Whippet around because we want to reuse it.
Okay. Justin?
Chair hat off, HTTP SIG author hat on. We obviously had Jose before we had HTTP SIG, and we made a deliberate choice not to use Jose when developing HTTP SIG, precisely because there were mechanisms inside of HTTP that allowed us to work within HTTP and HTTP's assumptions and data models and security models better than applying Jose would let us do that. So this is all to say, I fully agree with Joe's take that when we get to gRPC, maybe there's some protobuf thing that actually fits better than Jose, which is very JSON based. Or maybe if we're on Kafka, I don't even know what Kafka uses, or somebody's using MQPP or something other might have a way to express the same requirements and the same security needs and fulfill those needs that that we are seeing with Whippet. So it may be an abstraction that is not actually buying us what we think it's buying us. Again, we found that in HTTP SIG, and we made a very deliberate choice to not use Jose.
Yaroslav.
Yeah, I second what Justin just said. Another example I wanted to bring up is SSH. SSH is weird in many ways. They have their own certificate thing, not X509. They have their own key format and so on and so forth. And yeah, I don't really see a good way to plug Whippet into that, but there could be a much more native way for SSH to embed workload identifier that would be much more, again, native to SSH and would deliver better security properties than some kind of forced add-on on top.
right. We are now at 5 minutes. I want to make sure that we have enough time to wrap up. I saw that the queue had been drained. Want to give folks a second if anybody else wants to jump in for a parting shot. Brian?
Wouldn't be me without a parting shot. I do want to reiterate that the design goal of the Whippet was very much intentional application to HTTP to be included in HTTP header and to provide sufficient proof of possession for the request. So while a lot of this discussion has been around its application elsewhere, it and very much was intended to be applied to HTTP. Thank you.
Thank you. That is great perspective. So at this point, what I am seeing, and Peter, please corroborate or correct this, is that the authors in the working group have a decision to make of whether or not this doc splits, as Arndt is showing on the slides here. Like I mentioned as a note earlier, we are free to chop this up and serve it however we see fit. There are benefits and drawbacks from each approach. There is no one single right answer, and there's no one universal way that this ends up working well across IETF. And I can give examples of both and tell you the good parts and bad parts about both all afternoon. So does this sound about where we're at, Peter? We need to decide kind of from a structural standpoint where we're going with this.
Yeah, I think I've heard cases for both mechanisms. I think I've also heard desire to preserve, like Whippets for sure, even if we made one choice versus the other. I agree. There's a couple of document choices, and I to summarize, right, I think I've heard one that says keep everything in one document as is today. The other one's keep everything in one document, but move Whippets into an appendix with appropriate qualifying text. Another one is to say break it out into two documents. And then the third option is let's separate out credentials from authentication mechanisms.
From the presentation, yeah.
Presentation, and then we end up with maybe 3 or 4 specs, right? Because you might have one for X509, and you might have one for Whippets and one for HTTP signature. So I think those are the 4 options. I mean, I kind of want to put it back to the authors, maybe, or the editors even, to have a view here as well.
So I've actually got a proposed line of work for the authors and the folks that want to see things change, and this is something that I've been a part of in the past. It's much easier to get mad at something if you can see it. So those who have an idea of how this could be structured, please submit an individual draft that does those changes. So Yaron, if you have an idea of like, take the Whippet stuff, put it into its own section and sort of cordon it off, great, let's take a look at that. If the authors can, as an individual draft, not as a working group draft, show us what this split would look like, that would be very helpful. But the biggest thing I want to tell this group is let's not forget that the IETF works on rough consensus and running code. I am genuinely concerned at the amount of nobody's implemented this, but we're positive it's going to be a great idea when we get there, that I'm hearing in this work. Go build it and bring that development experience. It doesn't need to be scaled to billions of nodes, but go check it out, go try it. And that's how we really push things across the line. We are at time. We're probably going to get kicked out of the Meet Echo. I'm not sure how they do that with interims, but thank you all for hackathon topic. Great idea, Joe. I just wanted to pull that from the chat. Really great idea for a hackathon topic for Montreal. Thank you all so much. The next meeting is in, I don't remember, it's next week or the week after, but it's coming up. You'll see an update on the mailing list about that ahead of time. Please bring your thoughts to the list. Please bring your implementations and your IDs to the list as well. Thank you all for taking the time. Peter, anything else?
That's it. Thank you. And Arndt, I think to your question, we have consensus, I think, in this meeting, and so there's a task on the authors to come and show us potential futures. And I think, Justin, I really like your call for if there is anybody out there with implementation that can validate some of the assumptions that whippets are more useful than just for HTTP. That would be, I think, very useful for everybody thinking and reasoning over this topic.
Absolutely. All right. Thank you all, and we'll see you again soon.
Yep.